Hello everyone, the following is an introduction to the system design of the MR practice module. The name of our project is EasyResearch, and the topic is the thesis recommendation system. This introduction contains two aspects, system architecture and the technical details. The first thing that needs to be introduced is the system architecture part. As can be seen from the figure, our system mainly consists of three parts, namely a web server, rule-based paper recommendation, and NLP-based paper recommendation. First of all, the web server is responsible for interaction with users, including user registration, login, and other behaviors, and has its own user database for data storage. Secondly, it will request results from the two paper recommendation subsystems respectively, according to the user's request conditions. The two recommendation subsystems have their own data source and find results that meet the needs of users in their own ways. Next, we will introduce in detail the various links in the system. Our web service is developed based on the Django framework of Python. The URL dispatcher maps the requested URL to a view function and calls it. The view function performs the requested action, which involves searching for the paper to be recommended. The model defines the user data in Python and interacted with it. After completing any request task, the view returns an HTTP response object containing the paper details to the web browser. Finally, templates typically return HTML pages. We use Opta Planner to conduct the knowledge-based recommendation part of our system. Opta Planner is an open-source constraint solver that can do optimization of planning problems. It is consisted of mainly three parts: planning entity, planning fact, and constraint. Here is the planning entity, user, and the planning fact, paper. Among them, user is inputted from front end while paper are saved in database. Here's our constraint. In short, the system would calculate the similarity between 5 pairs of fields in Opta Planner and the user, accumulating all similarity and choose the paper with the highest score as solution. There is one thing to note is that title constraint is calculated between required title and keyword, which is extracted from paper abstract in order to improve calculation efficiency. Our similarity is calculated based on 2 gram distance. We use 1 minus bigram distance multiply 100 as similarity score. The reason we multiply 100 is that Opta Planner can only accept integer type score, and below is the equation of bigram distance and example of how to calculate it. This is the dataset we use. Archive dataset with more than 1.7 million papers after pre-processing. Final database is shown above, except fields of class paper. ID field is used as primary key and paper ID is used to generate URL. There are 2 key contents in an NLP-based paper recommendation, namely keyword extraction and matching. In the process of keyword extraction, we use the text bank algorithm, which is based on PageRank. TextBank is an algorithm widely used in keyword extraction and text summarization. This algorithm represents words and the relationship between words in the form of graph. Then use the topological relationship of the graph to update the weight of the node, which expresses the importance of the word. First, TextRank algorithm constructs a word network by looking at which words follow one another. A link is set up between 2 words if they follow one another. The connection gets a higher weight if these 2 words occur more frequently next to each other in the text. On top of the resulting network, PageRank algorithm is applied to get importance of each word. The top 1/3 of all these words are kept and are considered relevant. After this, A keywords table is constructed by combining the relevant words together if they appear following one another in the text. When dealing with text data, we need to represent it in numbers to be understood by the machine. Counterfactorizer is a method to convert text to numerical data. When the text data is vectorized, we use cosine similarity to evaluate user input and keywords extracted from the paper, and then return to those papers with the highest similarity. Thank you.